This week we moved to a new technology called web-based GIS, and I want to talk a little bit about the three technologies that we've used so far. You used a little web-based GIS last week when you migrated from the National Atlas. So, let's see if I can move this down. So I want to talk about that and then take a look at the desktop GIS, and in a couple weeks we're going to move into actual desktop. So when we think about GIS technology or geospatial technology, it really involves several types of applications. The software that we use on the computers, the data, and also the idea of remote sensing and GPS. So it's not just one piece of technology. And I think it really has this continuum from a very simple technology to incredibly complex technology. And the merging of these is pretty astounding. A couple years ago, the digital map, or the digital map National Atlas didn't have a link to web-based GIS, and the ID tool did not provide information about latitude and longitude. So I'm even seeing those kinds of things change. So I think in terms of complexity, this is, this is kind of how they look. The digital atlas is probably the simplest of the technologies. The layers are here. You can scale in and out. You can't add new layers or do overlays, but they do have multimedia links, and there's not a lot of analysis you can do with these other than just kind of visual pattern recognition, being able to talk about location and then speculate on influence and the other kinds of ideas. Virtual globes are kind of a step up in complexity. As you saw, you can add KML files, you can add your own data, you can they're very interactive. You can change the scale, you can change the units from UTM to lat long, you can measure distance, you can no longer measure area. This is a little bit old. The area measurement tool now has to be included in a pro package, so that's a pay-for-use application. But virtual globes are more interactive and a little higher skill level. And then desktop GIS, which we will attempt to use in a couple weeks, is still fairly underused for K-12 classes, just because it has been in the past expensive. The hardware to run it is expensive. Trying to keep your lab updated, getting the ability to actually load it in your lab is difficult. It's hard to learn. Although we're going to try working with a freeware application, and this is, if you look at this desktop, this is ArcGIS, and if I were to open that little toolbox, you would see about 400 possible tools that you could use, and so you can imagine trying to figure all that out. But with the desktop GIS that we're going to use, I'm going to just show you a couple tools that you can use that will allow you to gather data and share it with your students on Google Earth. So you can use desktop GIS almost just as a transport medium. But this week you're going to work with a product developed at Lane Community College through a National Science Foundation grant called GeoStack and Maps GIS that is focused on a web-based application, and the application was developed to look a lot like the desktop application ArcGIS. So with this application, you have a lot of options to look at data and evaluate data, but there are still limitations. You can't add your own data. You don't need software, which is a positive. You don't need very high-speed computers. You can do this with dial-up, although it's pretty clunky. You're really limited to the data that the developer has put on the website. The nice thing is that you can zoom in and out. You have measurement tools, as you saw in ArcGIS Online. You can do area, you can do linear distance. You can add overlays, so you can have data that's on top of each other. Really nice thing about this application is you can do Boolean logic queries that let you select special data applications. You can use the identify, you can download your data into an Excel spreadsheet, and you can create spatial buffers. So you'll do all of that when you work through the tutorial. Here's a list of some of the lessons that were developed by high school and middle school teachers in Oregon and other states in the country, and some of the lessons that they have developed. So as you look at data classification, one of the important things about spatial data is that there are attributes or there's information and location connected together. So let me see if I can open up and drag this into the view window. I've never tried this before. Yeah, I'm going to add this over here. So here is an example. Oh, I think I just lost. Yeah, shoot. Bum. I think I just lost the recording. Shoot. Maybe not. Let's see. Oh, no, I'm still good. I'm so sorry. Let me put this back. Isn't this fun? Technology is great. Okay, so here's the application, the tutorial that you're going to work through, and I'm going to click on the link to the map, and what you see are data layers on the left. I can expand this data layer and turn on the map, or turn on the layer. I can zoom in. So I see these nice dots. The big purple dot is more population, but the really powerful thing is the ability to open up the attribute table. And the attribute table is data that's associated with each of those location points. So there's the population, and then I can also do what's called a data query. So I can say I want the map to identify or select all of the populations in the U.S. that are greater than 100,000, and you can see that the data was selected out of the 593 cities. 231 of these have a population of that amount, and then I can also copy that to a clipboard. I can open up Excel and put that data in and show that as charts and graphs. Now that is selected, I could also create a buffer around those, which would be a spatial area. So you're going to work through looking at those kinds of things this week in the tutorials. Let me scoop back ahead. So with a web-based GIS, you have the ability to look at the data layers like the National Atlas, but you also have the ability to look at the data tables. So when we think about the data, we want to talk with students about the scale of the data. Are we looking at a global scale, national level, county scale, or city level? And then we want to talk about the type of data. Are we looking at points, lines, polygons? The example I showed you before showed each city as a point. I could have shown each city as a polygon, which would be the area or the outline of the city. So here is a map of election results. It's shown as polygons, so each state is a polygon, and the data is reflected as a whole state color. You could also show this as population, average incomes. Here's another polygon data set, and each polygon is a county in Oregon, and this is showing the number of people who have moved, or the population change from each county. And this is a choropleth map, so the darker the color, the more change in population. And so you can see that Multnomah County and the northern or the central part of the I-5 corridor has had more population change or gain, and some of these eastern counties, drier areas have had population loss. And here is polygons again shown on a national scale or on a countrywide scale. You can also show data in a very small areas, as in zip areas or census blocks. Data can be shown as point data. So here is address data as a point showing the number of burglaries in a certain area in Eugene, Oregon in 2006. You can also show that by latitude and longitude as points. So you can include a lot of the Gershmill thinking skills. So you can look at a web-based map and ask students to talk about crime patterns. Let's go back to this. You could ask them to talk about them in as far as using relative location and cardinal directions, so east of the highway, south of the grocery store. But you could also ask them to talk about it and give you the absolute, absolute location, whether it would be latitude and longitude or street addresses. Then you can ask students to look at patterns. So here are two different crime patterns. One is burglary location, the other are linear patterns showing traffic accidents. The burglary locations look more clustered. The crime pattern or the accident patterns look more linear. The other thing that really has an effect on this is scaling. So if you were to zoom in to this particular area in Eugene Springfield, these dots would look less clustered. So one thing you can ask students to think about is, are you looking at this on a national scale? Are you looking at it on just a local scale? And then we can ask students to think about correlation, which are positive correlations showing that places are both high or low with respect to a specific trait, or negative correlations and looking for just opposites in a way. So here is an example of a negative correlation between life expectancy and fertility rate. Fertility rate is high, life expectancy is low, and that's a negative correlation. And over on this side would be a positive correlation where fertility rate is high and infant mortality rate is also high. Students also think of positive correlation as having a good result and negative correlation as having a bad result. And then of course being able to talk about scale and the impact that scale has on analysis, just as in the crime patterns. If I zoom out on the state, you can really see the crime patterns as a very tight cluster in Eugene, but when I zoom in, not so much. And the web-based GIS will let students look at spatial thinking and ask logical questions. So where you look at a Boolean logic scenario of something having both traits. So all the cities with a population of 1 million and they're in California would give you a narrow selection. But if I said all of the cities with a population of 1 million or in California, it would have a much larger selection. And then the not would be an exclusionary operator. So with ArcGIS or with web-based GIS online, there are many options that you can do to really enhance student spatial thinking. And then the last piece would be to look at spatial buffers, and you're going to do this in the tutorial as well. And the spatial buffer is just identifying an area around or along a feature. So you could look at exclusion zones along a river. Where are you not supposed to build, or where do you need to plant riparian vegetation, and what would be maybe the influence of pollution around a certain feature.